Hello everyone and welcome to another video of Zahner. This is Vikas Sadiq. I'm an application specialist and marketing manager here in Zahner. In this video I'm going to talk about cyclic voltammogram. Previously I showed you that how you can draw a baseline, measure the peak height and peak positions, and how you can integrate peak area. Today we want to go one step further and to analyze all the cycles of the cyclic voltammogram simultaneously. To better represent the cyclic voltammogram, this time I will choose the linear I versus time plot preset. In this plot preset I have current versus time representation, and what I want to do is that I want to integrate all these oxidation peaks and these reduction peaks simultaneously. For this, let's get started. First of all, we have to draw a baseline. For this we go to the insert or edit baseline. I will just draw a baseline at 0 current. So this will be my baseline, and now I want to integrate the charge. For this we go to integrate charge. Now in the toolbox it shows us that what we have to do, we have to provide the starting point of the graph and the end point of the graph. For providing the starting point of the graph, we can go to the graph, right click with our mouse and make a new cursor. This cursor 1 is automatically selected here, and then go to the end of the graph and then make a new cursor by right clicking with your mouse. This cursor 2 is automatically selected for the end of the graph. And now if I integrate charge, I will integrate all these oxidation and all these reduction peaks. So let's integrate charge, and now all the peaks are integrated. The results are shown here. Here you can see that we have baseline over 2 cursor positions, and here is our integrated charge. What we see here is that the 3 anodic peaks are shown here as positive, which has the charge of 7.07 millicoulomb per centimeter square, and these anodic peaks have the charge of 5.78 millicoulomb per centimeter square. It also shows the net value, which is the difference between the positive and the negative value. That means this is the difference between the anodic and the cathodic peak. So if you have multiple cycles and you repeat this process, at the end it shows that if your material has oxidized or reduced. So this is a very nice feature of Zahner Analysis. Now allow me to introduce you to another very nice feature of Zahner Analysis. For this we have to go back to the linear I versus U plot preset. Now go to the data sources window and click on the active file. Right click, go to properties. This opens up a new dataset properties window. This window provides you all the information which you provided during the measurement in the Zahner software. Here we have the information about the system, temperature, the time it was measured, the slew rate. If you had any comments, you can write your comments here. One very nice thing is that you can choose the reference electrode potential. For example, right now silver chloride is chosen, but let's say that you were using columnar electrode. So you choose the concentration of the columnar electrode, and then you click apply, and you will see that this y-axis will shift. Now it has adjusted your cyclic voltammogram regarding this new reference electrode. You can also choose a user defined element, and then you have to provide an offset. Here you have to decide what was the offset. If you click 0, then it will shift the whole value by the difference from the previously chosen value. In the Zahner software you have the option to do the correction for the ohmic drop. If you did not do that there, you can do that here. So you choose the ohmic drop resistance and then you click apply, and it will do the ohmic drop correction. Another very nice thing is that you can provide the area of your electrode. Right now 1 centimeter is chosen. If you choose 2 centimeter and you click apply, this y-axis will change. You see here the y-axis has changed to the half of the previous values, and if we go back, the y-axis will double than what was given before. And another very important thing is that when you are changing the area, your y-axis should be in amps per centimeter square. If it is in amperes, you will not see the difference in y-axis by changing the area. And how do you change from amps per centimeter square to amperes? By clicking on this icon, and if you click again, you go back to amps per centimeter square. So keep this in mind, that if you change the area, then you have to make sure that you are in amps per centimeter square y-axis setting and not only amps. So with this we came to the end of our video. In this video I showed you that how you can integrate all the peaks of your cyclic voltammogram simultaneously, and how you can change the setting for the reference electrode, the ohmic drop correction, and the electrode area. With this I thank you for your time and see you in the next video.